This is the first of the lectures on production function. The production as a word we understand in economics as creating utility. For instance, someone is singing and that singing doesn't give you any uh, pleasant experience. Then would you call that as production of music? You don't, because it doesn't give you any utility in terms of enjoying an art. Whereas when a professional singer is giving a concert, then that concert gives you the satisfaction of having listened to some good music. Then that production of music can be called as production because it creates utility. Similarly, there is a piece of wood which has been cut by a carpenter, and that wood doesn't add any utility for us. Then the work of the carpenter in making a wood, a piece of wood, cannot be qualified for being called as production. So basically, we understand production as something that creates utility. How that utility is created, how that production really happens. It happens by converting inputs into output. Sometimes it can be more than one output also. For instance, if you look at agriculture, we are using land, water, seeds, human labor, some machinery like tractors, electricity. So all these inputs are converted into an output. Or take the case of weaving a cloth. That means there is cotton converted into a thread, and thereafter thread is weaved into a cloth, dyed, and colors are given. So there are, in each of these processes you will find lots of inputs being used, and therefore those inputs are getting converted into output. You can consider any activity that creates utility as production. It can be a service. For instance, even transportation is a productive activity because it transports goods from places where it is produced to places where it is being consumed. Therefore, transportation is also a productive activity. Uh, Storage, for instance, is also a productive activity because we store goods at a time when it is produced and deliver it at a time when we need to consume, so for which we need storage. So most of the activities that we do that ultimately adds value to the commodity that ultimately we consume, then that activity can be called as production. And production needs a technology to convert inputs into output. So this is what you'll have to bear in mind, that production needs a technology. Without a technology, production cannot happen. And production function is considered as a technical relationship between inputs and output. And mostly we have a mathematical equation for a production function, but we can also conceive that as an idea where Q is the output and it is a function of land, labor, capital, and organizational skill. When we mean this in terms of a functional relationship, what do we mean? We mean that certain quantities of land, labor, capital, and organization together create some quantity of output. So there is a relationship in terms of magnitude. The magnitude of land, labor, capital, and organizational skill, as these things have a quantitative relationship with the output unit. It can be some kilometers of cloth, or it can be some kilograms of wheat, so on and so forth. So there is a quantitative relationship, and this quantitative relationship is actually determined by the technical relationship, which we mean that there is a technology that decides how the quantitative relationship happens. So a good technology may require a little amount of all these factor of production for a given amount of output. A bad technology would require lots amount of all these factors of production for the same given amount of output. So the technology that decides the quantitative relationship between inputs and output. Normally, we give a functional equation like this where L represents land, labor, capital, and capital also includes the organizational skill, or you can put it as O, which is an organizational skill, as the fourth factor of production. But for simplicity, let us assume that the output is related to only land and capital, labor and capital, because we assume that capital is having land, K represents land as well as organizational skill. Then we can simplify a production function as Q as a technological relationship with labor and capital. Usually this sort of a general functional notation where Q is a function of Lk, it can also be expressed in terms of a graph, or it can be in terms of an algebraic equation, which we will see shortly. So uh, in short, a production function gives a technically the most efficient combination of factors of production and output. So every production function gives technically the most efficient. This is the part you will have to understand, because no producer would use a technically inefficient uh, production function. Therefore, every production function represents the technically the most efficient combination of factors of production and output. What is supposed to be the most efficient? If suppose there is a technology A which is considered as the most efficient technology, that means there is no other technology which can produce the same amount of output with less amount of factors of production. That means this particular technology A uses the least of the factors of production for a given amount of output. Production, actually, a technically efficient production need not be economically efficient. That is what we'll have to understand. So I would say that uh, technically efficient need not be economically efficient. What is economically efficient production? A production that maximizes profit should be technically and economically efficient. So no doubt a technically efficient production function is needed for an economic uh, efficiency, but technical efficiency alone is not enough, whereas we need an economically efficient technology. Where, how do we determine the economically efficient technology? The one that gives the maximum profit. So normally we represent profit by pi, which and cost, which is a function of prices of inputs. So when I am talking about a economically efficient production, then actually my economically efficient production function is determined by the prices of output as well as by the prices of inputs. So I have two other uh, factors that determine what is an economically efficient production. So technically efficient production is one that uses the least amount of resources, but economically efficient production is a level of production that gives the maximum profit, and that maximum profit depends on the price of output and price of inputs, and the relationship, all that we will see in the later lectures that I would be giving. But for the time being, it is important that we understand what is technically efficient production, what is economically efficient production. So economically efficient production is one where we have a level of output that gives the maximum profit. Technically efficient production is one which uses the least amount of resources for producing a given amount of output. So this much you will have to understand. Any factor of production or economics in general, we have to uh, think about uh, always in terms of time. This is a very important aspect in all economic analysis. So whenever I consume certain things, for instance, I have food, I may eat about half a kilo of vegetable every day. That means I need half a kilo of vegetables per day, or half a liter of milk per day, or I need about 2 pairs of dresses a week. So, whatever we consume, whatever we use, we always have with reference to time. So, time is an important dimension in all economic analysis. So, never forget that we use time as one of the reference marks whenever we talk about quantities. So, based on the time, we differentiate production function as short run production function and the long run production function. So, a short run production function is a period of time when the producer cannot change the quantity of at least one factor of production. I'll give you one example, you will be able to understand this. Let us assume there is a tea shop near our university. Now, that tea shop has a space, a shopping space. Then it has certain uh, instruments. Now, and also has got uh, certain other inputs like milk and coffee powder, so on, and some amount of labor. Now, this coffee shop, if it wants to increase the cups of coffee that it is going to sell, then can it increase the space all of a sudden? No, because suddenly it cannot increase the space of the coffee shop, but it can hire more amount of utensils, it can buy more amount of milk, or it can make some more laborers to come to the shop. So what happened, this particular thing is not, cannot be varied in a short period of time, let us say in a period of 6 months. So 6 months is a period of time which we call it as a short run, because the space the shop has is called a fixed factor. So it is called a fixed factor, that is the quantity of space cannot be increased or changed, whereas the instruments, milk and other things, they can be changed. So we call that as variable. So what happens in a short run is a period of time when the producer cannot change the quantity of at least one factor of production. So he wants to increase the number of cups of tea that he is going to sell, but he can increase only by increasing instruments, milk and labor, but not space in a matter of 6 months. If it is 1 year, he wants to increase his output next year, then he has got a lot of time to rent in more amount of space. So long run is the period of time when the producer can change quantities of all factors of production. That means he can hire one more shop space, he can get one more shop space, and of course he can buy more amount of utensils, milk and labor. That means all these factors of production become variable in the long run. So long run is a period of time when the producer can change the quantities of all factors of production. So we understand that production function can be uh, understood in a short run where at least one factor of production is constant or fixed, and we call that as a fixed factor, and there are other factors of production which can be changed, we call that as a variable factor. Sometimes there can be more than one fixed factor in a short run, there can be only one variable factor in the short run, those things are different. But all that we understand is a short run has got fixed factor, variable factor, whereas in the long run all factors are variable. Now let us understand a short run production function. Normally I said Q is a function of L and K, whereas L is labor, K is capital, which includes land and organizational skill. I have assumed that K is constant, that means this is a fixed factor. So one fixed factor and one variable factor. What is the fixed factor? Fixed factor is capital and the variable factor is labor. Now Q is called the total product of labor. Why Q is called the total product of labor? Because we assume that the change in the output is because of change in labor, because the capital is fixed, so you are not going to change that. So any change in output is because of change in the quantity of labor that we are going to use. So that is why we call Q as the total product of labor, because the change in Q is due to change in labor as K is constant. So this total product of labor is written as Tp suffix L. Now there is an average product of labor which is equivalent to total product of labor divided by number of units of labor used. So this is one way. Say for example 100 units produced and there are 10 laborers, then uh, 10 is the average product of labor. Similarly, we can also talk about the marginal product of labor, something like marginal utility, which is the first order differential of the total uh, product of labor to labor. So this is how we understand mathematically how the average product of labor and the marginal product of labor are done. So this is a mathematical representation of that. I said production function can also be algebraically represented or graphically represented. Now this is an algebraic representation of a production function. So where Q is a function of or equals 0.01 L K dash. What does it mean? K is constant. Similarly 3L square K dash. 0.1 L cube K dash. So suppose I give a value for K, then Q becomes a function of L. In other words, the total product of labor is out of changes in labor alone. If I change the value of L, then TPL will change. Suppose I give L equals 1, then I will have 1 plus 30 plus 1. So 32. If I give 2, 2, here L squared is 4, 4 into 30, it becomes 120. Then L cube is 8. So 130 plus 8 plus 2. So 140. So this is how the total product of labor changes with the quantity of labor that we are going to use. The average product of labor I had already mentioned, it is Q by L. What is Q? Q is this. So Q by L, it's once again a function. Similarly, the first order derivative of Q, that is this to L, which is equivalent to 1 plus 60L plus 3L square. Now derivatives you would have learnt in your mathematics class, that's why I am not explaining this part. How did I derive this? So actually this 2 comes before 2 into 30 into L, where it is 2 minus 1, so it is 60L, and 3 comes here, it is 3 minus 1, so it is 2. So this is how an algebraic form of shortened production function is explained. We can also go in for a graphical function. So it is something like an S, this part is called the total product of labor. If you represent that previous equation, if you use this equation and give 1, 2, 3, 4 for labor, then you will have a graph like this. Now this graph, it has 3 phases. Up to 10, what happens? The total product of labor increases at an increasing rate. This is important. Up to 10, the total product of labor. What is 10? 10 units of labor. Up to 10 units of labor, the total product of labor increases at an increasing rate. Thereafter, it is increasing but at a decreasing rate. Then after that, it declines. So this is how it works. Now, from this, I can also calculate the marginal product and the average product. So if I calculate the marginal product and average product, this is what I get, the shapes, the shape of marginal product and the shape of average product. Now when it changes, this is called the point of inflection. When the point of inflection changes, at that point the marginal product of labor reaches a maximum, after that it declines. Here it becomes 0. So understand, when the marginal product of labor is 0, total product reaches maximum. This is one point you will have to remember. What is it? When marginal product of labor is 0, then total product of labor is maximum. This is a point that you will have to understand, this point. Similarly, at this point, the marginal product and average product are same, that is equal. So I can prove that using this. That is, when a function is maximum, when the first order derivative is 0. So Q by L is called the average product of labor. When I do the first order derivative from the previous equation, I have shown you the equation here. Um, for instance, this equation, if I do the first order derivative of this equation, then I will get it as this one. And if I do that as 0, that is the first order derivative is 0, then I will equal that to 0. So if I equal that to 0, what happens? I rearrange that equation. I take this q by L square to the other side, it becomes minus q by L square. 1 by L I take to the other side, it becomes L. So this L will get cancelled with this, it becomes q by L. What is q by L? Q by L is the average product of labor. What is dq by dl? It is called marginal product of labor. So when you are equating the first order derivative of the average product equation, remember, once again I tell you, when you equate the first order derivative of the average product of labor equation to 0, then you will find rearranging that will show the marginal product is same as average product. So this is called a mathematical proof that marginal product is dq by dl equals q by L. What is q by L? It is average product of labor at this point. Normally, the production will happen somewhere between 15 to 20. This is where you will find the maximum economically efficient output. This is the maximum output, technically efficient output, but economically efficient output will be somewhere between the two, depending upon the factor prices and the product prices. So this is the efficiency range between 15 to 20, because that is the place where the average product of labor is declining. Only in this space you will find there is some economically efficient production that will happen. But how to determine that, we will see later when we do the cost curves and the revenue curves. At that time you will be able to understand what is economically efficient production, that is the profit maximizing production. So all that you will see at that point of time. Okay, so this is what basically the preliminary ideas about the short run production function. In the next class we will see the long run production function. Thank you.